or if, you know, their pathfinding algorithm was a little bit off. Only the students know exactly. So this North Dakota robot has an interesting digging mechanism. The digger, which is basically a backhoe on an arm, is actually mechanically coupled to their onboard hopper. So as their backhoe arm comes in, the onboard hopper automatically moves out because they're mechanically coupled. So there's no way mechanically for them to crash into each other.
I'm not sure who we have over there operating the cameras, but they're getting us some amazing shots of the action going on in the arena right now. So I just want to give them a special shout out and say thank you.
Yes, our production team, our public affairs and education folks are knocking it out of the park. They are giving us, the audience, wonderful, high-resolution, zoomed-in views that the students in the control room who are operating and monitoring these robots, they don't get these wonderful views. Now look at the intensity of the students. They're up out of their chairs and they're like leaning in to their computers. That is just awesome focus right there on the University of New Hampshire side. Okay, now you can see a little bit of material coming up out of that auger on the New Hampshire side. Meanwhile, on the North Dakota side, this robot is digging a lot, and it appears to be digging deep. So this is good stuff. Now, I don't know if you can tell from the camera view, but there is a grate in the upper right. There is a wire mesh grate on the North Dakota robot that this backhoe is dumping into. And so the soft, light, dusty material falls through that grate and actually flows right out the bucket. They don't want that stuff. We're interested this year in the rocks that are buried beneath the topsoil. And so the rocks will actually sit on top of that grate, and then the bucket lifts up and then they fall back into a hopper. Very, very creative and innovative design on the North Dakota State University robot.
So it sounds like North Dakota State is playing for the win because they're trying to grab the large pieces of regolith to bring back to the judges' scoring area.
Yes, the rocks and gravel that we have hidden underneath the topsoil is simulating icy regolith, or chunks of ice, and that's what they're going to get scoring points on if they're able to collect. Now, those might be rocks. Did you see that? Those might be rocks. There's no guarantee because sometimes this soft, fluffy regolith gets compacted, and it makes things that look like rocks until the judge, you know, crushes them up and realizes that they're not rocks. Only the judges at the end of the event will know. Now look at the students in the lower right on the North Dakota State side. I'm guessing that they're fully autonomous right now because I don't see a lot of focus, a lot of like driving going on. They're just monitoring the system as it runs autonomously.
It looks like they're very happy with how their run is going so far.
Look how deep that bucket is going. We're losing sight of it. It's going so deep. So I have hope for this North Dakota State University team that they're getting rocks. New Hampshire on the left looks like they're heading back. It's hard to see during that digging operation how much material, especially rocks and gravel, that they were able to bring up. But as soon as they dump it, as soon as they get back to the starting position and unload using that onboard conveyor belt, which is white in color, we'll be able to see what they've collected so far. I love it when the teams use like a white colored conveyor belt because then when the gray material sets on it, we can actually see it. A lot of these robots are gray in color, and the material that they're collecting is gray in color, and sometimes it's hard to see.
So we got less than 4 minutes left. If you were in the control room right now, what would you be doing? What would your strategy be if you're one of these teams, seeing how much action and regolith they already have accumulated?
So you saw how fast that New Hampshire robot got from the starting position to the digging position. So, you know, they only need like 10 seconds to get back to the starting position, to the dumping position, assuming the robot is facing the right direction, which it is not right now. It has to get the conveyor belt in the direction of the, oh, there's a crater right there. But a four-wheel drive robot should be able to get out of that, I would hope. But I don't see all four wheels moving, and that's where the problem comes in, if they don't have enough power on these wheels. But it's not as easy as just adding more power to your robot, because all the judging criteria that are involved in this competition make it hard. They make it hard to have a heavyweight robot. Okay, North Dakota is coming back with 2 minutes and 45 seconds remaining.
I'm going to be interested to see if New Hampshire can get out of this crater that they're stuck in right now. They've already collected a ton of regolith, it looks like, and I wonder if they're going to be able to get out of that hole.
That North Dakota robot went over its exact same tracks, even though it wasn't like a straight path. It went over its exact same tracks. So its path planning algorithm on board is telling it exactly where to go. That wasn't a mistake. But now it has to align itself. You can see these barcodes that the students have installed basically on the hopper, which is the lander. They're allowed to install sensors and visual cues. They're able to install things on the lander that the robot uses to help figure out where it is in the arena and where it needs to be.
So when you see those barcodes in the arena, does that guarantee that they're using an autonomous system?
It does not guarantee. There it's dumping right now. Look at that. Those rocks came out right away because they were the things that were dug last, and so they were on top. That is really impressive. Now watch the judge. They've got a sifter there, and they'll make sure that the soft topsoil goes down into the sifter, and they'll actually remove by hand the scoring rocks. So when you see a judge pulling handfuls out of that bin, those are scoring rocks that they're going to go ahead and weigh separately, and to make sure that that team gets credit for those scores. So that looked like a really good run for North Dakota State University. They still have a minute left. They could have dug a little bit more, but if they're running fully, look at the high fives all around. I know Nicole in the lower right of your screen there was in charge of the autonomy, so I know she is just completely excited right now. She used to be one of my interns, so that is a really good run for North Dakota State University. I know they are super excited about that run, and we will find out later. We can't give you real-time data as to how many rocks, how many kilograms of rocks that this team just dug. And sadly, as time runs down, University of New Hampshire is looking like they're not quite going to make it back in order to show us how much that they were able to pull up. And being their second run, that's especially sad because that's basically going to be it for this competition. There are other awards that these student teams can actually win besides the team who excavates and deposits the most rocks. Let me go over some of the other awards that these teams could potentially win this week. There's a Communications Power Award.